at locus. What is locus? So look at this question. Find the equation of the locus of a point. Is different from the word locus, which is the insect. This is locus. Locus, locus. Okay? Okay, so what's a locus? Have a look. So the locus of a point P, which moves so that it is always 4 units from the origin. I'm going to show you an animation. Oh, not this one, this one. Okay, watch this. So this point is always 4 units away from 0. Now, as I move B, guess what will happen? So let's put trace on. Yeah, so can you see trace out a circle if the distance is always 4? Okay, so what's the equation of the circle? So it must be a circle of radius 4, right? So you go x squared plus y squared equal to 4 squared. Does that make sense? Yes. Which is x squared plus y squared equal to 16. That's the equation. All right, any question? So we can see how visually how it works. The next question is, how do I do it algebraically? So what you do is, you draw the diagram, start with the point P, which has coordinate x, comma, y, and the distance from the origin is always going to be 4. So we use the distance formula, PO equal to 4, and to get PO, we use the distance formula, x minus 0 square plus y minus 0 square equal to 4. And if you simplify that, that will be x squared plus y squared square root equal to 4. And to get rid of the square root, we square both sides, which is the same. Okay, so you can do it this way as well, same. Right? So that's how locus works. So in this topic, in this exercise, you're going to learn how to find the equation of a graph given a description. So in this case, the description was the point is always 4 units from the origin. You get a circle. Right, let's look at another question. What if I change the question slightly so that it is always 3 units from the point 1, comma, negative 2? Let's try to draw it. You go 1 across, negative 2, so that's the point. And the point P moves in such a way that the distance from that point is always 3 units. So you use the same rule. You can just use the distance formula. Let's call that point A. PA is always 3 units. And use the distance formula, x minus 1 all square plus y minus negative 2 all square equals to 3. Distance formula, and you work out, so you go x minus 1 all square plus y plus 2 all square. I'm going to square both sides to get rid of the square root, and you end up getting which is equal to 9. So which is basically the equation of a circle. It's an equation of a circle with center at 1, negative 2, and the radius is equal to 3. All right, make sense? All right, cool. All right, let's move on to the next question. What's the next one? Find the equation of locus so that it is always 5 units from the y-axis. Will you get a circle this time? Maybe not. So let's see what you get. So you get, this is a circle, right? Next one. All right. Find the equation of a point so that it's always 5 units from the y-axis. So the best way is to draw it. And the point always moves so that it is always 5 units from the y-axis, right? Always 5 units from the y-axis. So what do you expect to get? You get a vertical line. X equal to 5. Is there other possibilities? You can get minus 5 if you go on the left direction, right? So it doesn't say which way, just 5 units. So you get, so basically x equal to plus or minus 5. All right, 2 equations. All right, all good? Yep, like that. Okay. All right. Okay. All right. Okay. All right. Next one. Okay. Let's look at the next question. Find the locus of the point P so that it is equidistant from the point A and point B. Let's watch this. Okay. So you get this graph. You get the point A, which is 2 across 3 up. And the other one is -2, -1. And it's equidistant from A and B. So this time I get a different graph because equidistant from 2 points. Okay? Sorry. No, I'm just changing the screen. All right, let's try again. Algebra stuff. Locus. All right, good. It works now. All right, watching. All right. P is equidistant from A and B. Okay, let's see what happens when we move C. So when we move C, if it's always keeping the same distance from the other 2 points, what do you get? You get a straight line, isn't it? Right? So let's find the equation of that straight line. So what we do is we use the distance formula. So we'll call that point P, x, y, and we use the distance PA equal to PB. Right? PA is the distance, so you go x minus 2 all square plus y minus 3 all square equals to the distance from B, x minus -2 square plus y minus -1 square. Yep. And then what you need to do is to get rid of the square root like we did before, and then you end up getting x minus 2 square plus y minus 3 square equals to x plus 2 square plus y plus 1 square. Unlike the other one, we actually get a circle. Due to the fact that you got squares on both sides, you won't get a circle this time. You will get a straight line. Let's see why. We're going to expand everything. X squared minus 4x plus 4 plus y squared minus 6y plus 9 equals to x squared plus 4x plus 4 plus y squared plus 2y plus 1. And then if you cancel things, you'll see that the square get cancelled like that. And then you move all terms to the left side, so you get -4x minus 6y plus 4 plus 9 minus 4x minus 4 minus 2y minus 1 equal to 0. So move all the remaining terms to the left and collect like terms. So you end up getting -8x, -8y, 13, that 4 got cancelled, 9 minus 1 is 8. And what do you end up with? You divide everything by -8. Divide both sides by -8. And then you end up getting x plus y minus 1 equal to 0, which is, of course, the equation of a straight line. X plus y minus 1. Okay? So what's the question? Alright, this is the first method to do. I'm going to show you another way to do it, which is faster. Alright, I'll show you much faster. No expanding, no squaring. I'm going to show you. So what I'm going to do is to copy this diagram. Alright, so we've got this diagram again. So what we're going to do is, this line will be perpendicular to this line in here. So if I join A to B, the locus will be perpendicular to it, and it's going to pass through the midpoint. So it's going to be the perpendicular bisector of the line AB. Okay? So what we do is, we're going to find the midpoint of AB, which is 2 plus negative 2 on 2, 3 plus negative 1 on 2, which is equal to be 0 and 1. Yep. And then the other one is the gradient of AB, which is equal to 3 minus negative 1 over 2 minus negative 2, which is 4 over 4, 1. But the gradient of the locus is the negative reciprocal of the other gradient. Now watch how we can do that very quickly. We use the point gradient form, and we can work out. So we get y minus, alright, so we continue y minus 1. Actually, we've got the y instead. We can actually skip this step, but anyway. X minus 0. So you end up getting y equal to negative x plus 1, or you can move it to the other side, which is same as before. So you can use both methods, but you got to recognize it. Whenever the questions say equidistant from 2 points, you can use this shortcut, but only works for that. For this one, equidistant. So, all right, excellent. If you finish, let's move on. I'll make it bigger for you. I moved the minus 1 over. Oof. Yeah. Yep. Everyone's different, so some people might prefer first way, some people prefer the second way. Because like we know this locus will be perpendicular to AB. That's why I need to find a gradient. So I know what direction would this line go. The gradient tells you which direction, whether going down or going up. Yep. And you use the point gradient form. Alright, so we need to do more. 2 more questions. Next one will also have a animation I will show you. Okay, hopefully you're ready. Alright, let's move on. 1, 2, 3. Let me just unfreeze. Okay, thank you. Move on to next page. Next one, watching. Find the equation of the locus of a point P such that PA perpendicular to PB. So let's see what that means. So if I draw the diagram, A is negative 1, 3, and the other one's 3, 1. Right? And then we say P is the point such that PA and PB are perpendicular. So what do you do? If they're perpendicular, you find the gradient. So you find the gradient of PA, you find the gradient of PB, and then times them together to get negative 1. Let's try that. So you go y minus 1 x minus 3, pretty easy, y minus 3, x plus 1. And their product is negative 1 because they are perpendicular. PA perpendicular to PB. Right? Alright, good. So now there's some algebra involved. So let's do this. PA is y minus 1 over x minus 3 multiplied by y minus 3 over x plus 1 equal to negative 1. And what you need to do is to expand the numerator, expand the denominator separately. So you have to do y times y minus 3, etc. Okay? So what do you get? You get y squared minus 4y plus 3. Remember, you just have to add these two numbers. Negative 1, negative 3, you get negative 4. Times them together, you get 3. That's a shortcut. Do the same thing at the bottom. X squared minus 2x minus 3 equals to negative 1. And the next step is to get rid of the denominator. So multiply both sides by x squared minus 2x minus 3. X squared minus 2x minus 3. Right? So it cancels the denominator. And you end up getting y squared minus 4y plus 3 equals to the negative of that. So what we do is you need to move all terms to the left side. So move this one to the left. So it becomes x squared minus 2x minus 3 plus y squared minus 4y plus 3. Now guess what that equation represents? It's a circle because it has got x squared and y squared. How do I find the center of the circle? You complete the square. That's why we did the 10.3 before we do this exercise, so we know how to find the center. So we're going to leave a gap like before. Y squared minus 4y, leave a gap. And whatever that doesn't have the x and y, you move it to the right, or they get cancelled anyway. That's good. So you end up getting, so what do you have to add? You have to add 1 squared to both sides, add 2 squared to both sides. Like that. And what do you get? You get x minus 1 squared plus y minus 2 squared equal to 5, which is indeed the circle. You'll notice that the center of the circle, because it's a completing square, you halve the 2, you square it, so you can complete the square to find the center. So the center is 1, 2. You'll notice that the center is exactly the middle of AB. Right? No, that's the midpoint of AB. Right? And the radius will be root 5. All good. All right. Thank you. All right, let's complete the square. We did that last lesson. The top bit, gradient of PA, gradient of PB. Because it's perpendicular. All right, okay. Yeah, so you actually trace out a circle. So I could just draw a dotted line. It's a circle of radius root 5. It's a circle. Now I could show you a picture of this, watching. Watch this. So I see PA and PB. Watch how it works. That's 90 degrees. It traces out a circle. Yeah. If that's always 90 degrees. Does that make sense? All right. All right, good. Now you see how it works visually. All right, hopefully we can continue. We've got 2 more to go. And then we'll do a summary of all the locus. All right. Actually, we've got 3 more. So today's a lot of algebra today. Yeah, we'll do that next lesson. No, it's focus. Yeah, that's a good point. Focus. Yeah, I don't know. You have to ask English teacher the question. Okay, let's move on. Okay, find the equation of a locus of a point P such that it is equidistant again, but this time equidistant from a point and a line. So in this case, you will get a different graph. Let's see what we get. Again, let's draw a picture. And you get the point 0.04, which is here. And get the line, which is over here. Okay? So you get the locus of a point such that the point P, the distance from this line point, is same as distance from this line. Okay? So I'm going to call this point A. And call that point D. Okay? And we're going to say PA and PD are the same because it's equidistant. Now XP again will always be the unknown point, x comma y. The point D will be directly below P. So they must have the same x value, but the same y value on the line, which is -2. Right? So now we have to use the distance formula. So we do PA, which is x minus 0 square plus y minus 4 square, like that, equal to PD, which is x minus x square plus y minus -2 square. Like that. So what do we have? So like before, we need to square both sides to get rid of the square root because the distance formula has a square root. So we end up getting x squared plus y minus 4 square. The x got cancelled, which is 0 plus 2 square. And possibly it could be a circle, but we cannot be certain because the x squared, there's no x squared term here. So we're going to expand everything, see what we get. So we get y squared minus 8y plus 16 equals to y squared plus 4y equal to 4. And you notice that the y squared got cancelled. Right? And then let's move things across. So you go x squared equal 8y minus 16 plus 4y plus 4. And we're going to collect like terms. So we get 12y minus 12 x squared. And what type of graph do you get? This is a parabola because I only got x squared in it. And I could show you the sketch. The sketch will look something like this. We're going to study this a bit more detailed later on. So you get a concave parabola. Yeah. That's the locus of this. All right, hopefully you're done. We're going to move on to 2 more examples. Parabola because it has an x squared in it. See? X squared is a parabola. But if it has got x squared and a y squared, it's a circle. If it's got one x squared, it's a parabola. Does that make sense? How do I get what? All right, let's move on. Next page. All right, let's move on. Next one. Okay, watch this. Okay, I'm going to draw this line here. 3x minus 4 plus 7 equal to this. So we're going to draw a line there. 3x minus 4y plus 7. We want to find the equation of the locus such that it is always 6 units from this line. So 6 units from the line could be here. 6 units. 6 units, perpendicular distance. So you will expect to see a line here or a line above, right? So the question is, how do I find the equation of these 2 lines? So we have to use the perpendicular distance formula. So let's do that. So we're going to use the perpendicular distance formula. So let this point be P. P is x comma y. We're going to measure the distance from P to this line. Okay? So P is x comma y. And the distance from P to the line is exactly 6, so we use the distance formula. And P is x comma y, so you go 3x minus 4y plus 7 over 3 squared plus negative 4 squared. P is this one on the green line. That's distance from this line is 6. And that is 6, right? And you get 3x minus 4y plus 7. And if you use your calculator, you get 5 at the bottom. And then you multiply both sides by 5. And then you get, say again, after I finish. So we get 30, with that 3x minus 4y plus 7. Like that. And what do I do with the absolute value? You get two possible equations. So we get 3x minus 4y plus 7 is 30, or 3x minus 4y plus 7 equal to negative 30. And then you end up getting 3x minus 4y minus 23 is 0, or 3x minus 4y plus 37 is 0. That's the equation of the two lines. Okay? So we got these two. Right? So that's how we find the equation. Actually, it's written here. Oh no, I give it to you so you can check it. Yeah. So answers. No, I wrote it there so you can check it. Yeah. All right. So basically, the locus is the two lines parallel to the first line. They are all distance 6 units from this line. Okay. All right. Next one. After we finish, the next one, I want you to try that for yourself. Practice yourself. Practice yourself. So PA equal to 2PB, just use the distance formula. And then you will end up getting this, and you will get a circle. Okay? All right, have a try later, because I'm going to do a summary. All right, let's do a summary of all the locus that we've encountered in this topic. So we'll go to the next page. Okay, equidistant from one point on page 8, you will get a circle, right? Equidistant from one point. And what's the method? Use the distance formula. All right, so you just go P here, and that's A. PA equal to some number, all right, which is that number is the radius of the circle, so you get a circle. Or distance from 2 points, equidistant, is the perpendicular bisector. So that's the point P. Okay, so it's going to be a perpendicular bisector. Perpendicular bisector of AB. Alright, so you get a straight line. So you just have to do PA equal to PB. Again, distance formula. Okay. We also saw equidistant from a point and a line. We saw that in the other example. Point and the line. Let's use a different color so you can see the point and the line. Alright, good. So in that case, you have the point P x comma y, that's A and that's D. So you go to PA equal to PB, right? And in that case, you end up getting a parabola. Parabola. Okay, see the difference from equidistant from 2 points, you get a line. But that's equidistant from a point and a line, you get parabola. And we'll study about parabola later on in more detail. But now you see you get different shape depending on what condition you're given. Okay. And we also have, see, there's a lot of different types of the equidistant. There's 4 different types. Equidistant from one line. What do you get? We'd see that in the other example. You get 2 lines, right? A pair of lines. A pair of lines. So basically, if you look at it graphically, I start off with a line, and the equidistant from this line and this line, right? Equidistant. And you end up a line here or a line there. And in this sort of example, you use the perpendicular distance formula. Perpendicular distance formula. Okay. So we see the differences. So make sure you recognize which one's which. That will save you time to do formula. Oh, it's equidistant from a point and a line. How do you visualize that? I will do an example next lesson and show you how it works. I've got a worksheet that you can go through and we'll see why you get parabola. Okay? Alright, next one, what's the other one? What if you get equidistant from 2 lines? We didn't do that example, but I will show you now. You get that in the textbook. So you still get a pair of lines. A pair of, let me write it properly, a pair of lines. Alright, so a pair of lines. But the difference is, the first one, a pair of parallel lines. And this one, a pair of intersecting lines. Okay, so let me draw a diagram so you see that example later on. So you get 2 lines here, 2 lines, and then this line will be equidistant from these 2 lines. So you get a line here, or you can get a line there, right? That's the locus. Again, use the perpendicular distance formula. Okay? And then the last one, PA perpendicular to PB, we did that. PA and PB, that's A, that's B, P, that's B, right? If they're perpendicular, use the gradient formula. PA times PB equal to -1. You get a circle. You get a circle. Like that. So we got all covered. So you get pair of lines, you get parabola, you get lines, you get circle, you get everything. So everything can be described geometrically. So it's quite interesting, isn't it? Yeah. I forgot what I'm going to write here. So I think linear means that when you see an equation that looks like this, that means it's linear. Means a straight line. Straight line. So the equation looks like this in general form, or equation look like this, horizontal line or a vertical line. Horizontal, vertical. Right? And then you have quadratic, which will look like this, which you'll get a parabola, parabola, Or you could get this one. You get a circle. You get a circle. Right? So if there are 2x squared and y squared, it's a circle. If it's just 1x squared, you get a parabola. Does that make sense? I think that's all. There's plenty of things you have to do today. Make sure you start the exercise now and ask questions. Yeah, we'll leave it on the board. Thank you. Yep. Yep.